Let's try again. Hey guys, welcome back. Just want to say you guys have done a great job the past 2 days of getting things done and turned in for the most part. If you have not completed your assignment for Monday or Tuesday for math class, go to those assignment pages and complete them. That counts as your attendance and those things are graded. So please make sure you do them. So today we are going to talk about corresponding parts with our scaled copies. So yesterday we talked about scaled copies. Today we're going to talk about scaled copies a little bit more, but talking about corresponding parts. So get your math notebook and your pencil and make sure you have some things to write down. All right, so our learning target for today is I can identify corresponding points, segments, or angles, and I can describe the scale factor. Sorry, I want to present it for you so you can see it better. I can describe the scale factor for a figure and its scaled copy, okay? So before we do that, let's talk about pattern building. For our patterns, we are going to just talk about how math is patterns. So how do you see this pattern growing? I want you to pause this video for a second, think about it, and then come back and we're going to answer these questions. All right, so what does figure 10 look like and how many squares does it have? So I'm not going to draw figure 10, but what do you notice about each figure? Each column and each row has the same number of squares that the figure number is. So figure 10 is going to have how many squares in the column at the very end? It's going to have 10. Or how many squares at the bottom? It's going to have 10. Some people see it as building on the bottom. Some people see this as building on the sides. Some people see this building diagonally. So it's all in how you see it, okay? And then figure 55, you can figure it out, okay? So math is all about finding patterns in the world. That's what we're going to try to do this year is make sure we see patterns in things, okay? So let's just review what a scaled copy is. A scaled copy is just a copy of an original figure in which every length is multiplied by the same number, okay? And we already talked about that yesterday with our scaling F, and you guys did a great job with that. So, I don't know what happened to that thing, but let me show you this page. Maybe I'll stop sharing and share it to you. There we go. All right, so let's talk about corresponding parts. So corresponding parts are points, segments, or angles that are in the same place on the original and on a scale copy. So let's look at the original. Let's find point P. It's right here. On copy 1, this figure, where is the corresponding part? So it's the bottom, and it's on the right-hand side. It's going to be point F. So we're going to say F. I'm just going to put a point there. And then in copy 2, the bottom right is going to be Z. All right, now let's do segment LM. Let's find LM on the original. So that would be, let me get my highlighter. That would be this one. So LM. So on this copy 1, the same place would be BC. So I'm just going to say segment BC. And actually, you're right, line segment with a line over it. Sorry. And then on copy 2, it would be VW. All right. And I'm going to skip down to the bottom real quick. Let's do an angle. Angle KLM. So I'm going to use a different color. I'm going to do KLM. You name an angle by the points that make up that angle, the segments that make it up. In copy 1, let's look at that same angle. It would be ABC. Copy 2 would be UVW. Okay, so I've got angle ABC in copy 1 and angle UVW in copy 2. I want you to pause the video for a second, and I want you to fill in the rest of this table. All right? Okay, folks, I filled in the rest of our table. So segment EF in copy 1 correlates with OP in the original and YZ in the copy 2. Point W, point C, point M are all corresponding points. Angle KLM, we already did that one actually. Angle XYZ, DEF, and NOP all correspond, okay? So corresponding parts means they're just in the same exact place on the copy and the original, okay? So the question I have for you is, are either of these a scaled copy of the original? Let's talk about it. So we don't have any measurements like we did yesterday. So we're gonna look at the angles this time. So what I want you to do, I want you to grab some paper, notebook paper, whatever you wanna use, and I want you to trace one of the angles, okay? I know you can't see it on my screen as well, but what I'm gonna do is I'm gonna trace one angle because I don't have a protractor to actually measure it. And then I'm gonna move it to copy 1 to that exact same corresponding angle and see if it matches. And then I'm gonna move it to copy 2 and see if it matches that one. All right, so that's what number 2 and 3 are. What you're gonna find is that they correspond in copy 1, but not in copy 2. So copy 1 is going to be a scaled copy of the original, but copy 2 will not be. So let's talk about what that means for us. Okay, here it is. So that's what I'm trying to show you is if you did the tracing, copy 1, it correlates perfectly. Copy 2, it does not, okay? So one more thing we're gonna do is we are going to talk about the idea that sometimes we don't have sides that are easily measurable, like if you have a triangle or a rhombus like this. So we're gonna find segments across the figure, okay? So I'm gonna measure segment DB now. So I'm gonna measure from D to B and H to F, because these are corresponding segments, and L to J. And I'm just gonna measure how many squares they take up. D to B is 4, H to F is 6, and L to J is 2. Now let's measure the vertical. Now, if you notice, these are not perfectly on a cross section of squares, and that's okay because I'm just gonna measure from one line to another, okay? So I'm just gonna measure that vertical. So I've got 1, 2, 3, 4, 5, 6 here for AC. For GE, I've got 9. And for KI, I've got 3. All right? So that's just a way you can measure it. And what we can do is then say, okay, are these proportional or scaled copies or not? All right? But I just want to show you that because your activity tomorrow will have some that are not super easy. Okay? So let's go back to this. All right. So what have we learned today about scaled copies? We talked about corresponding sides, which from yesterday, they have to be multiplied by the same number, which is also called the scale factor. And then we talked about corresponding angles in a scaled copy. They have to have the same measurement. And then other vocabulary we've talked about today, we have corresponding parts, which are points, segments, or angles that are in the same place on an original and a scale copy. And we've also talked about the scale factor, which is the number that you multiply by for each length to get that scaled copy. All right? So your activity for today, this is a PDF in Canvas for the assignment for Wednesday. You're going to make sure you answer in the yellow/orange boxes for each question. And make sure you explain, if it asks for number 3, make sure you explain it, okay? And then I would like to show you one more thing. You also have a notes assignment that you're going to do today. And I want you to copy notes because there's definite research that shows that if you copy something down, that's an avenue to make your brain create synapses and remember it. So I know that it seems like a lot, but it's really not. It'll take you 5 minutes. So you're going to have these notes in an assignment and you're going to copy these notes down, okay? All right, friends, I hope you have a great Wednesday.